and later on publish it to YouTube. And there we are. We are recording. Woo-hoo. And yeah, so it's Kapiel, Morris, Mike, Matthew, and myself, Robert. We will have a short introduction into GraphQL. We already talked a little bit about how to send queries. Now we're focusing on how to implement those resolvers. Maybe we will also sidetrack a little bit and have a look into the middlewares, which is yet another topic, like a plugin. But let's see. So right now we are looking at the build server of a pull request, and it seems there were some linting errors.
Yeah. So Kapiel, you open this. Yeah. If you're done with this PR and you're looking for an official review, like you can review, suggest or ask for reviewers, but also if you wouldn't mind like removing the work in progress.
Yes.
So do you want me to do that, or do you want to do it?
Yeah, I can do it. I can do it.
So just that way people can look at it at first glance and know that it's ready. And then also depending on, a lot of times, like if we're busy and we prioritize, well, we try to prioritize giving reviews when it's actually passing the build. But we can also have a look at if you're stuck on something, or if you want to have like a review for how far you've gotten, then we can also do that. And as Robert mentioned, at the moment, it looks like one of the reasons, at least, that it's failing the build is because of the linting errors.
Okay.
So what I would typically like, if I were you, try to get in the habit of doing is running the linting after you make changes to the front end or the back end. But I think in this case, you just made changes to the front end, right?
On the back end.
In the back end, sorry.
Yeah.
So I think I talked to you about the linting before, maybe?
No, we didn't talk about linting.
Okay. So we have in our, and forgive me if you already know any of this, but if you go to the package .json for backend or front end or anything like that, you have the scripts. Which means you can run yarn and then like build or yarn start or yarn dev and so on. And one of the things we have is yarn lint. And if you run yarn lint, it will tell you about any linting issues. If you run it with the flag fix, then it will not only tell you about any issues, but it will fix them if they are auto fixable. Sometimes they're not. Yeah. So it's I forget, Robert forgets, we all forget sometimes, but just try to get in the habit of doing this before pushing up.
It's not terrible at all. You see usually the build server failing, and then you get a mail, and then you say, I forgot linting errors, and then you automatically fix those. All the white spaces, it's just one command, and you commit that and push, and they're done.
And you can if you look at the difference, you might be able to tell what it was.
The comma.
Oh, the comma, yeah, comma's at the end. Yeah.
Use ESLint, by the way.
Yeah, and it tells you insert a comma on line 32 or whatever.
Okay.
And then maybe that's the only reason it's failing.
Yeah.
Looks like it. Yeah. So if you don't, I'll let you push up the. And Robert, this is you probably haven't seen this, but he added to the follows that created out with a default of now, or when it was created, and the followed by as well. And then for the shouted, added this as well, but the follow resolver actually uses Neoti, which you probably know because you were the one that added the code. Oh, actually, Vasily did. Okay. Yeah. Yep. So that was the only change needed is to change the Neoti model. And then for the shout, it uses a cipher query. So I think this might be why, Kapiel, you were working on this as your first issue and maybe trying to understand, like, why are we using, in some places we're using cipher queries, other places Neo4j, GraphQL.js, and other places we're using Neoti. And I think it's perfect for a question for you, Robert.
It is a good question. That's what I can say. We are already now deep in the middle of implementing those resolvers, and our struggle to find a good way of
Mhm.
connecting the resolvers with our database. And unfortunately, there's no good integration for
Yeah,
Neo4j into the JavaScript world.
yeah, yeah.
Have
I
you
see
ever?
for the Java world, we have Hibernate and all those things. But for the JavaScript, I thought there will be many, but I saw only one NeoD, and I
Yeah,
think it's written by some only one person, and not many pull requests or things. Not
absolutely.
famous.
Absolutely. So have you used Hibernate with Neo4j? I would be interested if Hibernate also supports Neo4j.
No, I have not used with Neo4j, only with relational databases.
Right, right. Yeah, with relational databases, usually
Yeah,
you're good off because there's a lot of support in the industry, and they have these
yeah,
integrations for all the languages, all the common languages
yeah,
at least. But Neo4j, it's
yeah,
used primarily by data scientists, and they are usually interested in the database only, and they write their queries and then
yeah,
they're
yeah,
happy.
yeah,
And it's hardly used as in a real world application with something that's facing a user, which you put online, where you have to worry about authentication and
yeah.
data validation and so on.
So, do you know if Facebook is using Neo4j kind of graph database, or they are using something else? Facebook or Twitter, what are they using?
Yeah, so I have no idea what Facebook is internally using. Probably they have built their own database. Who knows?
Yeah, yeah.
Um, but I know that Neo4j is certainly the most popular free and open source graph database,
Mhm.
and that there are some other graph databases out there. There are a lot of proprietary graph databases actually.
Mhm. Mhm.
Proprietary graph databases are a thing. So I know people who work in these fields. In my co-working space, there was one guy who was developer for a graph database called ArangoDB, which is a
Okay.
proprietary graph database, and they have, for example, insurances as clients. So big
Yeah.
corporates, insurances, they put all their data into this graph database.
Okay. Mm.
Interesting. So graph databases are used, and
Yeah.
apparently in the free and open source community, they're not as prevalent as they should be.
Yeah. Yeah.
Having that said, if you have the combination JavaScript and Neo4j, there are only two possible integrations that I found, which I know of. And one you already know, that's Neodi, which is maintained by one person.
Yeah.
And the other one is called Neo4j GraphQL.js, which is not
Okay.
only a JavaScript wrapper around Neo4j, but has a lot of responsibilities.
Okay.
It is supposed to be a glue code between GraphQL and Neo4j, but it is doing too many things,
Okay. Mhm.
and it's not doing all those things really well.
Well,
Okay.
I would say, but that doesn't mean it's not a good library. It's just a library that needs to be improved,
Okay. Mm.
right? It has
Yeah.
a great potential. It's just that there are a lot of things who are not suboptimal, I would say. And
Yeah.
our way of dealing with it or walk around with it is that we started to write our own mutations based on Cypher itself. That's like the query language for Neo4j.
Mm-hmm.
For the mutations and for the queries, we still use the auto-generated resolvers of this library,
Okay. Mm.
right? If you
Yeah.
git grep for Neo4j GraphQL.js in one word, lowercase letters, then you will see all those places in the backend where we still use the auto-generated resolvers. Now, why not?
Yeah.
Neo4j GraphQL.js in one word without hyphens. There we go. What?
it's with hyphens, no?
Oh no, it's without the JS.
Oh, yeah, for
Yeah,
GraphQL.
because it's an npm package and they don't need to. Actually, not too many. Really? Did we come that far? We are almost independent of Neo4j, for J, for J, GraphQL.js.
But that's just for queries, though, right?
Yeah, I mean, we use it for the post query, obviously, and we use it for the comments because we query the post and then if comments.
We don't use it for the comments. It doesn't look like.
Yeah, kind of. When you go to the post page and you want to have the comments, you get the post first, and it's comments.
Yeah. Okay.
Interesting.
That resolver, that custom resolver that we kind of add the comments to the.
I didn't know that we got so independent of it already.
Yeah, you might have seen by now. Mike put in a PR to refactor the rewards spec, and we're it's just waiting to pass the build and it's going to get merged in. So we're getting close to removing what is it? The GraphQL. No.
As a comparison, could you squid grab for the path that is where we get the Neo4j driver from? I think it's config/Neo4j. Is that correct? I don't know if you have to quote the search term. Maybe better do. Yeah. No. Let me see. If I go to, for example, to the users resolver, I see Bootstrap. It's Bootstrap/Neo4j.
Bootstrap. There you go.
Yeah, and we use that way more often. So we communicate with the driver directly, and we have strings where we put our queries in, and we basically implement it all ourselves. All right.
Yeah.
And Neodi, we use it sometimes because Neodi it's a wrapper, and it's also checking data validations. Most of the time, we're using Neodi only when we want to check data validations.
Okay.
And actually, I still haven't made an opinion or a final decision about Neodi because it's great, for example, for factories for testing purposes. And I haven't really made a decision if we want to use it in the production code itself.
Okay.
I think it's okay to have it there, but maybe we can even. Most of the time, I'm using it only for data validations and for nothing else because it doesn't really help to build the queries. The queries are not so complex after all.
Yeah. That's what I thought. Yeah.
It's different from writing SQL where you have really verbose, lengthy queries that you don't understand what's going on. With Cypher, it's very concise actually.
Yeah.
And it's possible to write the queries directly. So maybe we want to take out the validation library, which is called Happy, I don't know, HAPI. Matt, how we would pronounce it?
Happy? I don't know.
Happy?
Yeah, maybe supposed to be happy, but with like delta.
Yeah, right. Of course, happy. And now I understand the pun because it's a framework, and one of their dependencies, the validation dependency, is called joy. J-O-I.
Okay.
Yeah. Right.
Happy joy.
Happy joy. Yeah. Happy joy.
And that's being used by Neodi. And we could even implement our own thing that we use for data validation, and then we can still write our own queries, and we also can refactor our Neodi. I don't know. We really haven't made a final decision on it. We can use Neodi, no problem. And yeah, there's no good solution right now for anything. Like it's all bad in its own way.
Yeah.
For example, Neodi doesn't update this library I was talking about. Happy Joy is still Adam Carley. That's the name of the maintainer.
Yeah.
He didn't release any version that has the most recent main version. So it's still lagging behind. We actually we have this library as a dependency directly, and it's on, I think, version 4. And Neodi is using version 3. So I was quite confused when I wanted to implement custom validations, and I was confused because the documentation was saying use this API, and I ran into errors when I was implementing it that way. And turns out version problem. Yeah, long talk, little meaning. it can all be summed up into, we have a problem here, Houston.
I guess like maybe something really helpful, if I mean, assuming if you have questions, please ask, is finding something like, assuming you can fix the issue, the linting issue, and push it up, and we'll give you a PR review, but is to see if you if we can find something for you to work on.
Yeah. So some of my questions were, I couldn't see schema for all the queries that we are using. Where do we keep all the schemas? So what is the first place I go for any schema?
The GraphQL schema?
Yeah.
It's basically put into separate files.
Yeah.
There's the folder types or schema, I think, in the backend folder.
Yeah, you can come to backend, and then from backend you go to SRC. Here, backend, and then you come to SRC, and then you come to schema.
Yeah.
Then you come to.
I think the index in schema is putting it all together.
In schema.
No, schema.
There is a schema file as well, right? Separate schema dot.
There we go. So it's putting everything in one somewhere.
I said this is excluding what we want to exclude, right?
That is make augmented schema, which is coming from Neo4j GraphQL JS.
No, so it's types schema, maybe.
Maybe
types index.
Types index.
Yeah.
Yeah, there we go. So here's where we put all together.
Okay.
And it's not yet everything, because this library that I was talking about, Neo4j GraphQL JS.
Yeah.
The idea behind this library is that it's augmenting your schema. So you have one type and you get all the queries and mutations for free.
Okay.
Which I think is not the best idea. That's one of my biggest criticisms on this library, that it's doing this schema augmentation, which certainly helps for rapid prototyping.
Yeah.
Because you don't have to worry about hard coding the mutations and queries, which is great if you're one person working on some, I don't know, data science project. But it really sucks if you are a company or an organization who's building a social media app where you want to have full control over your schema. So changing the type has an effect on one query, 3 mutations. If you add relationships to it, you will get, for each relationship on both sides, 2 mutations more that get automatically added to the schema. So if your schema, your GraphQL schema, you put it into this library and you get another schema out. And the augmented schema is way larger than the schema that you put in.
Okay.
And we're trying to limit this to a certain extent. That's what you saw, where we have these excludes. So everything that we want to have full control over is being excluded from this schema augmentation process.
Okay. Okay. And okay. So so for suppose take example of follow flow. So the user from the front end will, I mean, they will call the API GraphQL API, right? And there it will post data to database.
The backend will do something with the request and then bring the data to the database. Yes.
Yeah. So where is the API for that call?
Maybe we want to go step by step. We first check the follow mutation. Matt?
Okay. Yeah. Sure. Yeah.
Please find the declaration of the follow mutation in the schema. Declaration, not implementation.
Yeah, I know. I started.
yeah.
You said it, the declaration probably is in, I don't think it has its own type, but I'll just check. No, it doesn't. So it should be in schema then. And then it's mutation and it's a follow user.
And what is this schema? Schema dot GraphQL. What's that?
This is like, we used to have everything listed in here, and
Okay.
then we started to refactor it into its own, because some of these are quite big, you know, like for example, post, and we have like the type declaration, and then we also have like certain inputs, and we have mutations, and we have queries. So if we were to add everything here to the schema, this file would be getting really long, and it would be more difficult for people to find where things are. So like recently, and we just removed this, for example, and we're kind of like working our way to like cleaning this up basically. But there's still some that kind of maybe makes sense to be in here. I don't know. Like, yeah, but I think that's the short answer.
Okay.
Yeah. So you can see two magic types here. You usually write your schema with this keyword type, and then you give it a name. And there are two magic types which are there by default, and that is query with a capital Q and mutation with a capital M. Those are your entry points, right? So these, everything that you put in there is a query basically, or a mutation. So if you have on line number 34, follow user, that is a mutation.
Yeah.
And you can see in the parentheses what are the allowed input parameters. In this case, it's ID, and it is not nullable, so you have to put it, give it the ID, and you get back as a response something of type user. That's it. That's all you can do.
Okay.
With Neo4j GraphQL.js, the auto-generated mutation, the mutation would be add user followed, and then you have to give it two input parameters, the ID of the user being followed and the user who is following, which doesn't make sense in our case because we have authentication, so we know who is issuing the request, and having the ID of the current user in the input parameter doesn't make a lot of sense because it's just redundant. So that's also one reason, a good example why we want to write our own schema and not augment it.
Okay.
Like, think of, we are putting off our training wheels. We started to learn how to ride the bicycle, and we get more and more grown up and learn how to write our own schema definition and declaration. So then what we have to give is an implementation of this mutation. With Neo4j GraphQL.js, you get all the declared mutations queries automatically generated if they follow a particular naming schema. For example, create, and then the type would signal to the library it's supposed to be a create statement, and you can create things. But if you implement your own stuff, and which is the case right here, we are not following the naming schema because we have, for example, this lowercase letter and so on, then we have to implement our own resolver. If we don't have a resolver, then we get an error once you want to call the mutation for the first time. Then the server will respond with an error, 500 error. The following mutation is not implemented. Right?
Yeah.
Actually, maybe we even get an error at build time. We probably get an error at build time because it knows the schema and it knows it must have a matching resolver. And if the resolver is not there, probably on server start, you will get this error. Matt, can you just remove follow user mutation altogether and start the server?
Yep. I think I just need to save, right? And it'll restart.
Yeah.
So for the follow user, we don't have any query, just two mutations, right?
Exactly.
Yep. It looks like it started, okay.
Oh, really? And can you call the mutation?
Yep.
Yeah, probably because this library tries to generate a resolver for everything, and it's not checking it at build time whether it's following the naming convention of this library. So you don't get an immediate. I think without this library, you probably get an error at build time.
Mm-hmm.
Yeah, you still need to request the user name, for example. Yeah, ID is good enough. Yeah, there we go. And this message doesn't come from Apollo server. So this message comes from this library that we're using. So it jumps in for all the resolvers which are missing. And if it doesn't know how to handle this request or how to generate the Cypher query or statement,
Mm-hmm.
it's showing you this error message. So this is a peculiarity of our application, that you don't get the build. Probably, I'm assuming, I have to check it out. If you have just the Apollo server, then I'm assuming you get this error at build time when resolvers are missing.
Yeah.
Good. But now you see, okay, you have to add the method in the, yes, now it's back. So there is, as you can see, on line number 5, we export an object here. Export default and then curly brace. That is, you export an object.
Okay.
And this object has can have type mutation as key or query, and it can have all the other types. So any response type, user, whatever. But let's start with the mutation maybe. So the first resolver, you can, in one request, you can have actually many calls to multiple resolvers. At least you will have a call to the follow user resolver on line number 7. Because the server knows the user has requested or has sent this follow user mutation, and it's looking for all the resolvers if we have a mutation, and in the mutation object if we have a method, a key with the same name of the mutation, that is follow user, and then it's calling it. Does that make sense?
Yeah, makes sense.
Right? So everything follows the same structure in a way. So your GraphQL schema has this structure. Okay, top level query mutation. These are your entry points, and they get reflected by the structure of the resolver. All right?
Yeah.
And then the method, you can see the method the method signature also on line number 7 behind the colon. So we have async, which is just a keyword in JavaScript for something that is that's an async method. So it could return a promise or it could wait for a promise. But then you have four parameters. And probably it's best to have a look into the Apollo server docs now, because it's easier to explain them with the docs. Matt, can I be the driver for a second?
Yes, please. I don't know if I need to release it or you release it. Yeah.
Nice. Kapiel, you're still with us?
I'm still with you. Yeah.
Cool. All right, so you go to Apollo server, and then you have a look at how resolvers are implemented, and blah, 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 blah. Defining schema basics, we covered that. Yeah, yes, this is like these are the textbook examples. You have type query, and then you have 2 queries, and they return array of certain type. Introspection. Okay, I don't find what I'm looking for. Apollo server resolver function, maybe? Or resolver method, resolver function signature. There we go. So this is what I was talking about. You always have these signature like this. You have the name of the mutation or the query, and then you have 4 arguments and some kind of implementation. And this object here maybe it's a little bit complicated to understand in the first place. We will see it later. This object is the so-called parent, or in this case called object, and refers to come on. Yeah. So this is a query. It's the user query. Yeah, my database has to restart, so that's why it's taking for a while. So you have a potentially very complex query where you can ask for the user and his contributions, and for each contribution you can ask for the title and for its comments and for their content, for example. So you get back a JSON object, which is an array of users, each user an array of contributions, posts, for example, and for each post in this array, again, a list of comments. Does that make sense?
Yeah.
So here we go. So we have the name of the user, no contributions, so empty array, that's perfect. But there we also have Jenny Rostock, a number of contributions, and one of it has actually comments, and they have the content, right? So 3 levels nested. And this object in a resolver definition always refers to the parent level. So if we in the user query, there is no parent because we are at the root level. But once this resolver resolves and returns an array of users, the user resolver will be called, and then the parent will be user, because that's the returned object. Yes. And then when you want to get the contributions, the parent will be the user object. Once that resolves, we go into the comments, and then the parent will be the contribution it refers to. All right?
Yeah.
So yeah, that's this object thing. It's kind of tricky at first, but it makes sense later on. Then you have the args. The args is pretty simple, pretty easy. The args is just what you put into the parentheses. So in this case, I guess, I can actually, for example, filter for name, Jenny Rostock. Yeah, that works. This is allowed. So we can, in the user query, we can add a filtering. So you're only looking for user with name Jenny Rostock, and then just get this. Then args will be for the user resolver, will be this here, the user query resolver. All right, but I can also put args if I wanted to, maybe here. Yeah, for example, first 10 or so, or first 2. There we go, right? So these are the args, and it depends what resolver you're in, what the args are. And then there's this context. The context is something that is the same for every request. Usually it has the information about the currently authenticated user. So we have here, we have a context method. Yes. So this context method gets put in here, and in our case, it has the driver, the Neo4j driver connection. Also reference to Neodi, basically same thing. The currently authenticated user, and the request, and cipher params, which is also the current user. So in every resolver, you can request the currently authenticated user. Does that make sense?
It makes sense. So it's kind of session thing, right?
Well, yeah, kind of.
The session context, or?
Well, if we don't really have a session because we have this token, this JSON web token that you send to the server, and then it gets decrypted and whatever is in this token is your current user, more or less.
Okay. Yeah.
But yeah, kind of, yeah. This is the, for example, request headers that get sent to the backend, and you can parse them. So for example, here we have this decode method that gets called on every request, right? It's going into the request comes here, and it's going to the headers and then authorization, and it's trying to decode the JSON Web Token there.
Okay.
And from that, we get the user. And we put the user in here, and suddenly all the resolvers have access to it. And then there's this obscure resolve info object, and the resolve info object has a lot of information. But why not source schema resolvers follow? Why not logging it out? Object. Params, context. Resolve. Yeah. What's going on?
Not much. No.
There we go. So mutation, follow user, ID U1. Oh, double quotation marks, U2 maybe. Yeah, why not? And then name. And yeah. And we get not authorized. And we see no console warning. And that is because I'm not logged in, but we can still change that. Log in, get a JSON Web Token. And then to the header. You saw where we decode the header, right? So
Yeah.
we have the header with the key authorization, and we put that here. And now we are authenticated. Right?
Yeah.
So we just followed the user with ID U2, and we get back the name of the followed user, and that's Bob the Baumeister. And if we have a look into the console output, so we start with the object, which is undefined because we are in the follow user mutation. So we are at the root of the whole thing, and it has no parent, which makes sense. And then we have the params, which is ID U2, and this is also really strange. We add those params by default. Don't worry about it. But this is what we actually pasted, what we put in as the user, which is the browser. All right?
Yeah.
And then there's the connext, apparently a typo, which should be the context. And there we can see that there's the driver, there's the connection to the database, Neodi, basically same thing. Here we have the user with a token and everything we need. So we are authenticated, we are Jenny Rostock, we're not disabled, we have an avatar, user ID, and so on. It's usually enough to know that we are authenticated. We have information about the request that came in, blah, 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 blah. The raw headers, a lot of things. And then we have the resolve info as last parameter. And in the resolve info, basically, the entire information about the query itself is put in. And most of the time, you don't have to worry about it. But for query builders like Neo4j GraphQL.js, this is being transformed into the database query. So it can always know what is the name of the query, what are the field nodes. So we have, yeah, so we probably would have to inspect this a little bit deeper. We can go down these fields and its arguments and its selection sets, which have then the nested information. But here we have, for example, the return type, so it knows what to ask for. Yeah, it has also reference to the schema itself. And then it can take that as an input and make a database call out of it. Does that make sense?
Yeah, it does make sense. Yeah.
And that's it. You're now an expert in GraphQL. Congratulations. I would say it's time for you to share your screen, Kapil. Because this is everything I have to say about the GraphQL thing.
Yeah. All right.
Seriously, this is it. All you have to know is the method definition of these resolvers, and you have basically everything you need at your hand. Now, I would be really interested in how we can help you. You want to contribute, I guess?
Yes,
And
I want to. Yeah. So can you see my screen now?
yes, I can.
Okay, cool.
Very well.
So let me open Shout. Before I open Shout, let me get back to follow. I have some questions.
Yeah.
So we have two mutation: follow user and unfollow user.
Yes.
Why in the unfollow user we are using Cypher, and in the follow user we are using NeoD?
That is because NeoD doesn't support removing a relationship. It's an unsupported feature. There's also a comment on line number 27. Note, NeoD doesn't provide an easy method for retrieving or removing relationships. It's suggested to use the query builder feature. However, pure Cypher query looks cleaner in my opinion.
Okay.
So it is just not supported by NeoD. Again, we are dealing with immature libraries here, which are not really production ready. And you can add relationships with NeoD by saying relate to, that is on line number 19. So you have a NeoD type, and then you can call relate to, and then give it another NeoD node, followed user in that case, and the name of the relationship. And then you create a database call and you relate the one node to the other with the given relationship type.
Okay.
And then you can, if that works out, and if that doesn't raise an error or anything, then you can return the followed user to JSON, which also returns a promise and finally resolves to a JSON representation of this node. But I'm really unsure if it's good at all to use NeoD in the production code itself.
Okay.
You could easily use Cypher query here or Cypher statement, as we do on line number 33.
Yeah.
And return, what is returned? And could you scroll down a little bit? Oh, we even use NeoD there. Interesting. So we only use the Cypher mutation or the Cypher statement to actually remove the relationship. Fair enough. But there are ways how you can, oh yeah, and we're using neod.cypher, which is just a wrapper around the JavaScript driver of Neo4j. In other resolvers, we directly communicate with the Neo4j driver.
Yeah.
And I think you have to first create a session, and then you have to call for session run, and then you give it a string, which is the cipher. Maybe just check out some of the other resolvers and see how it's implemented there. For example, the post resolver or Shout. Yeah, why not?
Shout.
Let's hope that, yeah, this is how it looks like. So you have on line number 6, you get the session object from the driver. So context gives you an object of these things I talked about, the current user, driver, NeoD, and so on. So you ask context driver, that is the driver for Neo4j, and then you say dot session, and then you get the session back.
Okay.
And with this session, you can say await, so it's also a promise, await session dot run, and then you pass on a string, and that is the statement that gets sent to the database directly. And you have format strings, we have ID here, type, and user ID. And you can see those on line number 8, for example, the ID and the user ID And where is type? Type on line number 9. So these get replaced with the arguments. And then you basically run the transaction. Yeah, but that is session run. Yeah, this will run the transaction. You get transaction res. What is res? Matt, do you know what res, what that refers to?
Results, I think. I don't know. I don't think it's particularly.
Result, probably.
Yeah, result or response. I don't know.
One of those. And then you get at least you get a res, transaction res. And then you get transaction res.records. And these records are the subgraphs that follow that match the cipher statement. So any subgraph that is a node with this given ID, which has a road relationship pointing to it, coming from another node, which is of type user, where the user. Ooh. What's going on? So we have node of which can be of type anything. So the node is being written by a user written. Interesting. So user written seems to be the author. You could also call it author. I would prefer author instead of user written. But and then there's another node, which is called user. Oh, and we just want to make sure we are not, the user is not the same as the author, apparently. Or something like that on line number 9.
Yeah.
Yeah, and then merge will also set up this relationship shouted between the two. So the user, which seems to be our current user, shouts this node.
The only thing is you need to wrap the date time in a toString function, because you can't use date times.
Exactly. So we have currently troubles with this integration with Neo4j datetime objects. It has a dedicated type in Neo4j, and the integration just fails to really give you convenient accesses to this type. And one workaround is to not use this type at all. Always use strings for the dates, which are ISO formatted. And if you get this datetime object and you just say toString, so toString and then parentheses and whatever is in there, this datetime object will be transformed into the ISO formatted string. So you can say datetime, but wrap this like wrap this with this toString method. Created at is just right because that's the name of the entity. But for datetime, you should have, or maybe you can also search for datetime where we use it in other queries, and there you can see an example how it's being used.
Okay, so it's a date time.
Exactly. All lowercase letters, datetime, and parentheses should give you. There's one example. Just the next. No, yes, this one.
Okay.
So here you can see an example how it looks like on line number 32.
Okay. Okay. Yeah.
Yes, and this will just transform your datetime object into ISO formatted string, and we don't have any problems anymore.
Okay.
You probably get we lose some extra features that this datetime object has, which we currently not use, so it doesn't hurt us.
Yeah. Okay.
Morris, hello again.
Hello, I don't know what's happening. It seems that every half an hour, every 20 minutes, I have a disconnect without any reason. I don't know. I have to check.
By the way, Mike and Morris, we're having this. I'm having this talk with GraphQL, and I haven't heard back from you if you can follow the conversation.
No. If I can't follow, I will tell.
All right, that's great, because I want to make it mutually beneficial for everyone here.
Yeah.
To learn something. Yeah,
Okay.
and that's basically it. And then you can say, yeah, you get this transaction rest thing. This has the number of records, so all the subgraphs, which I would expect would be only one. So
Yeah.
one record. And it is being mapped. So we take the is shouted from the record array. So on line number 11, you name this thing the count relation. So the statement, if the relation, the number of the relation is larger than 0,
Mhm.
this condition is, which is of type Boolean, so true or false, you name it is shouted.
Mhm.
And then this is being taken out of these records. And you can see on number 19, you see this destructuring operator, right? So const, and then square brackets, and then the name. This means take the first item out of an array. So we are indeed only interested into the first item of this array, which is an indicator that apparently this whole thing indeed just returns at most one record or nothing. And then we say is shouted and return this. So that we return a Boolean here. So apparently the whole thing here, this shout mutation, must return Boolean. Can you double check? Can you confirm, Kapil?
Yeah. Okay. So in
Right.
the GraphQL playground.
Exactly. You can say localhost 4000 and you just check the docs and see if the response type of shout is Boolean.
Okay. Yeah.
It's also declared in schema, I think.
It's also in
Yeah,
schema,
so-
of course.
Yeah.
Yeah. So shout is true
Mhm.
here. And how do I go to check the schema from?
You just check on the right hand side. There's yeah.
Yeah.
The docs are easier because it's you can search if you click on the doc instead of schema
Okay.
docs.
You can even search in the schema.
Or can you?
Yeah.
I'm gonna double check that. And just go believing.
In an earlier version of the GraphQL playground, they were coloring the search. If you search in the schema thing, this was always, I think, white. So if your background was also white, you couldn't see anything. So it was kind of a hidden feature for some people.
Yeah, I still can't see where to search in the schema.
Just Control F.
Oh yeah, okay. But that searches the entire page, right?
No, it is being captured by the thing.
Click on the. Yeah, okay.
So we are looking for is shouted.
Yeah, it's shouted.
No, I shouted. No, is shouted is what is being named inside the resolver. Just shout or unshout.
Shout. So this is query user. That's not what we're looking for. Query post, not either. You also not user shout dot shouted, not that what we are looking for.
It's a mutation.
Mutation. There we
Yeah.
go.
Yeah.
Mutation shout. Boolean, not nullable Boolean. So it will never be null. It must be true or false. Either or.
Yeah. Okay.
Right. So this is a problem because probably the resolver was implemented in a time when we didn't understood best practices around GraphQL.
Yeah, we didn't understand. That's why the follow was like this as well until Vasily refactored it to return the user, right?
Yeah, exactly. With the follow resolvers, I think we already have the response type user. So this will be the user who is being followed. And if something doesn't work, you just get null or something.
Mm-hmm.
And this is better because if you have this client, the client has its own cache. So the Apollo client has a cache and it can update the cache with the backend response. So you send one request, you get a response back, and this new object will replace whatever was in the cache before. And then it can automatically update the application without any further ado. So this is something that you should utilize. It's a best practice to return the object that you mutated.
Okay.
If
Mhm.
you have a deletion, then you would return the object that you deleted, and
Mhm.
null if you didn't delete anything because it
Okay.
was probably, for example, not there.
Yeah.
Similar to JavaScript delete, which also
Yeah.
returns the object which was deleted from an array if it was present.
Okay. Yeah. Sounds
Right?
good. Yeah.
So this is something that we should refactor, certainly.
Okay. Yeah.
Mike somewhere is jumping out, like getting excited about that word. Mike
Yeah.
loves refactoring.
Okay. Cool.
Yeah, I feel I don't I didn't get enough background to create the issue, but maybe if I say it, I will be corrected. So in this case, I don't know if we are creating a user and we want to return the user that's created in. We are creating a shout and we want to return the shout that's created, the mutation for the shout.
We want to return the user who's being, the post or comment that is being shouted.
Or the post
Right.
that's being shouted.
Post, yeah.
The post will be shouted, of course.
Yeah.
Yeah. You want to show the post. True.
Yeah, because we're getting confused with the follow. You follow a user, but you shout a post. So yeah,
Right.
we want to refactor it to, instead of return a Boolean, return the resource that's being, the relationship is being added to. In this case, a post.
Yeah, I will create that issue.
Awesome. I merged in your PR, by the way, Mike. So great job. We only have, I think we only have maybe one, two, 3 places, 4 places we're using GraphQL requests now.
Nice.
Yeah, the
That's
days are
awesome.
numbered.
Yes.
We are very close of getting rid of GraphQL.
I was quite surprised as well, because I didn't know you were even starting on the refactoring of the rewards. And then like Sunday afternoon, I checked the PR list and it's like, there's a PR that's already done and like passing the build and it just needs to be reviewed. Like, yes.
Nice.
Amazing.
Yeah. Once you get into this, it's pretty straightforward. Oh no!
Yeah.
Look at this. It's my alarm. It's 5 p.m. here now, and I
Oh,
want to visit my girlfriend in an hour.
Oh,
And I have to catch the
yeah,
train.
that's your number one priority.
Yes.
Production issue. Production issue.
Especially when we're recording.
Yeah.
All right, folks. So I'm gonna stop the recording.
Yeah.
But actually, we are. It's pretty convenient because we came to an end. Or what is your opinion, Capiel, Mike, Ono, Morris?
No,
I really enjoyed it, and most of my doubts are cleared, and I have a clear picture of what is being done here, and it's very helpful to me.
I think if
we
you
can always repeat this.
Yep. And I think if you're interested, I don't know, I got to check Mike's schedule, but we might do some pairing on starting on a feature that we will be working from the back end to the front. So if people are available, we'll share a
Yeah,
link.
yeah.
Or we
Yeah.
could stay here. Actually, Mike, are you even available?
Right now, I'm going to run the deploys. How soon do you want me to be available?
Whenever, like I don't
Yeah.
want to tell you when to be available. But
Yeah, maybe tonight. I'll let you know when I get home. I'm not sure if there's power at home though, so because there was power went yesterday and it wasn't back when I left. So yeah, I'll have to check.
All right, then.
Okay. Yeah.
I'm going to stop the recording, and I would say this was an amazing pair programming, and I'm
Yes.
really glad that you joined
Yeah.
us.
It is my one of the first pair programming session.
Oh,
and
it
I
was
really
the
enjoyed
first.
it. Yeah.
Seriously?
Yeah, seriously.
Wow. Okay, it's perfect. I love doing pair programmings because
Yeah.
it's the best thing you can do for knowledge transfer.
Yeah.
And IT companies, it's really, really important to share your knowledge, because skills matter, and you want your team
People
to work
go, people leave. Yeah.
together.
People leave. Yeah, people leave.
Exactly. People
Yeah.
leave. I always talk about
The bus problem.
the bus problem.
Yeah.
Exactly.
Yeah. First problem.
And pair programming helps to improve this, really.
Yeah. Yeah. In short time, you get lots of information, knowledge.
Yeah. Absolutely.
Yeah.
All right.
Thanks. Okay. Okay. Thanks, everyone. Thanks, Robert and Mike. Matt.
You're welcome.
Yeah.
Thank you.